Assume that a simple random sample has been selected from a normally distributed population and test the given claim. Use either the traditional method, which by the way is called the critical value method, or p-value method as indicated. Identify the null and alternative hypothesis, test statistic, critical values or p-value as appropriate, and state the final conclusion that addresses the original claim. So this question has significance level 0.01, and you want to test the claim that mu is greater than 2.85. The sample data consists of 9 scores for which x is 3.1 and s is 0.6. Use the traditional method of testing hypothesis. Alright, so in this case, you have to use the t-distribution because the sample size n is only 9, and s, the sigma, the population standard deviation, is unknown. Only the sample standard deviation is known. So that means you have to use the t-distribution, and for t-distribution you have to be aware of the degrees of freedom, which is defined as n-1 for our. Anytime you're doing t-distribution, degrees of freedom is n-1, and it will be 8 for this case. And then because you're using the traditional method, you have to find the critical value. But let's do first thing first. The very first step has to be to identify the null hypothesis and alternative hypothesis. And because mu is strictly greater than 2.5 is one of the claim, anytime you have a strictly greater, then that becomes the alternative hypothesis. If you have something equal to something, that's the null hypothesis. So we put mu equals to 2.85. Okay. So just remember, anytime you have equal sign, that's the null hypothesis. Anytime when you have strictly greater or strictly less than or not equal is this symbol, right? If you have one of those three things, then that's the alternative hypothesis. Okay, that's the first step. And then the second step, you have to figure out what's the critical value for alpha equal to 0.01. Now notice that this is one tail because it's an inequality, and because mu is greater than, that actually is going for this right tail. So we need to find the critical value for this case when you have the t-distribution and you want the significance level to be 0.01. And because it's the right tail, we mean that only this part is 0.01. Okay, so how do we find this value? Well, you have to use the inverse t, but inverse t gives you the value, this value when this left side of the area is given. And because this is 0.01, here it will be 1 minus 0.01. That would be the area, because the entire area is 1, right? So we're going to use inverse t, or you can also use the table of t-distribution, and you can go for that case when you're given 0.01. But let's use the calculator to do inverse t. Okay, on second vars, and then you do inverse t. Area that we want is 1 minus 0.01, and then the degrees of freedom in our case would be 9 minus 1, which is 8. And then you paste, and the value is 2.896 or 2.90 if you round it to the hundredths. So this is like 2.90. Okay. So that means anything greater than 2.90 would be the rejection inside the rejection region, and we will reject the null hypothesis. Okay, so that's step 2. So maybe I should say step 1, do this. Step 2, we found that the z critical, or t critical, because it's a t-test, t critical is 2.90. And then step 3, we compute the test statistics. T equals to x bar minus the mu divided by sigma or square root of n, but we don't have sigma, so we just use s, square root of n. And in our case, x bar is 3.1 minus our mu is given as 2.85 divided by s is 0.6 over square root of 9. And please don't forget these parentheses when you calculate it. So we need to do parentheses 3.1 minus 2.85, close the parentheses, divide, and then open parentheses, 0.6 divided by square root of 9. Then you close the parentheses, enter, and you get 1.25 as your test statistic. And therefore, the conclusion is because 1.25 is less than, so maybe I should write that down. So 1.25 is less than 2.90. So it's not in the rejection region, because we're using the right tail, so it has to be more than 2.90, but it's less. So the conclusion here is that we cannot reject the null hypothesis. Okay, so in other words, we cannot, there is insufficient evidence to prove that mu is greater than 2.85. Right. So that will be our conclusion.